In this video, I will discuss some fundamentals of logic. Logic is generally labeled as the science of reasoning. In order for a reason to be valid, a set of rules must be followed. It also provides forms and norms for the validity and acceptability of arguments. The study of logic helps an individual to increase his or her proficiency in reasoning and make a good judgment. First, let us have propositions. A proposition is a declarative sentence or statement which is either true or false, but not both. Examples: 2 is an even number. The sun revolves around the earth. And we also have examples for not propositions. What time is lunch? X is less than 5. So let us have more practice examples. Elephants are bigger than cats. Is this a statement? Yes. Is this a proposition? Yes. If so, what is the value of the proposition? The proposition is true because elephants are bigger than cats. Next, 50 is less than 10. Is this a statement? Yes. Basically, that is a mathematical statement. Is this a proposition? Yes. If so, what is the value of the proposition? That is false because 50 is greater than 10. Another, please do not run. Is this a statement? No, that is not a statement. Rather, that is a request. Is this a proposition? No, since that is not a statement, then that is not also a proposition. And lastly, we have x is equal to 2x squared plus 6x minus 3. Is this a statement? Yes, a mathematical statement. Is this a proposition? No, that is not a proposition because the value of x is unknown. Therefore, this statement cannot be evaluated as true or false. So that is proposition. Next is the compound propositions. When one or more propositions are combined or connected through various connectives is called compound proposition. We have here a table that shows the different connectives used in compound proposition. We have here a column for connective, which are and, or, if then, and if and only if, together with their corresponding symbols and type of statement. First, let us take conjunction. Let P and Q be two propositions. The conjunction of P and Q is the proposition P and Q, or symbolically, that can be denoted as P and the symbol that looks like an inverted V, Q. So that will be read as P and Q. This new proposition is true exactly when both P and Q are true. In other words, the conjunction is false when either one of P and Q is false. So let us look at the truth table of conjunction. So on the truth table, we have the given truth values for the proposition P and the truth values for the proposition Q. So when the proposition P is true and the proposition Q is true, therefore P and Q is true. If P is true and Q is false, therefore P and Q is false. Then, if P is false and Q is true, then P and Q is false. And lastly, if both P and Q are false, then P and Q is false. So as we can see from our truth table, the conjunction will only be true if both the propositions are true. Otherwise, it will be false. That is conjunction. Example. Let P be the proposition 2 is an even number. Let Q be the proposition the sun revolves around the earth. So we have the truth value for the proposition P, which is true, and the proposition Q is false. So the sentence P and Q is false since one of the component sentences, Q, is false. Next is disjunction. The disjunction of P and Q is the proposition P or Q, or symbolically, that can be denoted as P and the symbol that looks like V, Q. That can be read as P or Q. This new proposition is true when P is true, or Q is true, or both. In other words, it is false only when both P and Q are false. We have here the truth table for the disjunction. Given the truth values for the proposition P and the truth values for the proposition Q. So when P is true and Q is true, therefore P or Q is true. If P is true and Q is false, therefore P or Q is true. When P is false and Q is true, then P or Q is true. And lastly, when P is false and Q is false, then P or Q is false. As we can see from the truth table of the disjunction, P or Q will be false if both P and Q is false. Example. Let P be the proposition 8 is a prime number. Then, let Q be the proposition 11 is a prime number. So, we have the truth value for the proposition P, which is false, and Q is true. So, getting now P or Q, that is 8 is a prime number or 11 is a prime number. Or it can also be written as either 8 or 11 is a prime number. So the sentence P or Q will be true because at least one of the propositions is true. That is disjunction. Next is conditional. The proposition if P then Q, or symbolically that can be denoted as P and an arrow going to the right, Q, is conditional. P is referred to variously as the antecedent, the hypothesis, or as the sufficient condition, while Q is referred to as the consequent, the conclusion, or as the necessary condition. And we have here the truth table for the conditional. So we have here on the table the given truth values of the propositions P and Q. First, if both P and Q is true, then if P then Q will be true. If P is true and Q is false, then if P then Q is false. If P is false and Q is true, then if P then Q is true. And lastly, if both P and Q are false, then if P then Q is true. Notice from the truth table for the conditional, if the conclusion, which is in this case is the proposition Q, is false, then the truth value of if P then Q is false. But it will be true if both the hypothesis and conclusion is false. Example. Let P be the proposition airplanes make sound, and Q be the proposition airplanes are musical instruments. So we have here the truth value of the proposition P, which is true, and the truth value for the proposition Q, which is false. So the proposition, the compound proposition, if P then Q, we have, if airplanes make sound, then airplanes are musical instruments. Which in this case, the sentence, if P then Q is false. It is because your conclusion is false, which is your proposition Q. Next is the negation. The negation of a proposition P is the proposition not P, written symbolically as the symbol tilde P. The negation not P is true exactly when P is false. So the negation will be true if P is false. We have here the truth table for the negation. So we have here the given truth values for the proposition P, which are true and false. So the negation of true is false, and the negation of false is true. In other words, that is just the opposite value of the given truth value. Example, let P be the proposition square root of 2 is a rational number. So we have here the negation of the proposition P, which is square root of 2 is not a rational number. Or that can also be square root of 2 is an irrational number. Another example, let Q be the proposition 6 is an odd number. So the negation of the proposition Q, that is 6 is not an odd number. Or that can also be 6 is an even number. And let us have some practice applications on some fundamentals of logic. Write the following in symbolic form. We have three given propositions. The proposition P, President Duterte is a good president. Proposition Q, government officials are corrupt. And proposition R, people are happy. Number 1, we have the compound proposition. If President Duterte is a good president, then government officials are not corrupt. As we can see from this compound proposition, this is in if-then form. Therefore, this is a conditional. Then we have President Duterte is a good president. That is your proposition P. And government officials are not corrupt. That is the negation of the proposition Q. Then, writing this now in symbolic form, that is, if P, then negation of Q. Next, number 2, if government officials are not corrupt, then the people are happy. So again, this is in if-then form. That is a conditional proposition. Then we have government officials are not corrupt. That is the negation of the proposition Q. And we have the people are happy. That is the proposition R. Therefore, the symbolic form of that compound proposition is if negation of Q, then R. And lastly, we have if President Duterte is a good president and people are happy, then government officials are not corrupt. So again, this is in if-then form, that is conditional. And we have President Duterte is a good president, that is the proposition P. Then we have the connective and, therefore, this is a conjunction. So we will use the symbol that looks like an inverted V. And we have people are happy. That is the proposition R. And lastly, we have the government officials are not corrupt. That is the negation of Q. Therefore, the symbolic form of that compound proposition is if P and R, then negation of Q. And lastly, we have converse, inverse, and contrapositive. Suppose P and Q are propositions. Given the implication, if P then Q. Its converse is if Q then P. Its inverse is if negation of P then negation of Q. And its contrapositive is if negation of Q then negation of P. Example, we have here the compound proposition if P then Q. If this movie is interesting, then I am watching it. We have the proposition P, this movie is interesting, and the proposition Q, I am watching this movie. Getting now the converse, which is if Q then P. That is, if I am watching this movie, then it is interesting. Next is to get the inverse. That is, if negation of P, then negation of Q. First, we need to get the negation of P. So the negation of P is, this movie is not interesting. And the negation of Q, I am not watching this movie. Therefore, if negation of P, then negation of Q will be, if this movie is not interesting, then I am not watching it. And lastly, we have the contrapositive. That is the if negation of Q, then negation of P. So we need to get the negation of Q. That is, I am not watching this movie. And the negation of P, this movie is not interesting. Therefore, the contrapositive, that is, if negation of Q, then negation of P. If I am not watching this movie, then it is not interesting. So those are some fundamentals of logic. Thank you for watching, and I hope you have learned something.